Good afternoon, my dear students. How are you all? I hope you all are feeling well. This is your Rishan. I can help you to understand physics easily along with the numericals. In the last class, we have been discussing about the refraction of light. In the past class, we have seen how the ray bends towards the normal away from the normal when travel from one medium to other medium. And we have seen the laws of refraction and we know about the Snell's law. In the coming class, in this class, we are going to learn refractive index, the factors affecting the refractive index, the relative refractive index, hot air, cold air, density of the medium, and the least refractive index of the medium. That is, in this session, we are going to learn it. Let me see the refractive index. How can we say the refractive index? It is represented by N or mu. This is represented by refractive index. Refractive index represented by small n or mu. It is a ratio of speed of light in vacuum by speed of light in the given medium. It is a ratio of speed of light in vacuum by speed of light in a given medium, where c is the speed of light in vacuum. And v is the speed of light in a given medium. So the refractive index is the ratio of speed of light in the vacuum by speed of light in a given medium. The refractive index is inversely proportional to speed of light. When this is when c equal to constant. When velocity of light in vacuum is constant, the refractive index is inversely proportional to speed of light in the given medium. If we have a least refractive index, we find the more speed of light in that medium. If there is a more refractive index, what do you find it? Least refractive index in that medium. From this relation, we will write n1 by n2 equal to v2 by v1. As we know very well, the speed of light is equal to f lambda, where v is the speed of light, f is the frequency of light, lambda is the wavelength of light. We know during refraction the frequencies remain same, so we will write the speed of light is directly proportional to wavelength of light. More wavelength, more speed. Less wavelength, less speed. Shall I write here? The refractive index is inversely proportional to wavelength of light. More wavelength, low refractive index. Less wavelength, more refractive index. How we clear it? And this refractive index is a scalar quantity. The refractive index, the ratio of same type of physical quantity. So it do not have any units. No units. How we clear about? So what is the refractive index? The ratio of speed of light in vacuum by speed of light in given medium. Speed of light c is remain constant. N is inversely proportional to speed of light in the given medium. From this relation, we have written n1 by n2 equal to v2 by v1, and v equal to f lambda. The frequency remains same during refraction. So v is directly proportional to wavelength of the light. Then n is inversely proportional to wavelength of light. Okay, so it is a scalar quantity, no units. It is represented by small n and mu. Okay, after that, we are going to see here what is the factors affecting the refractive index. factors. Factors it is refractive index. The first factor is nature of the medium. Nature of the medium. Second factor is wavelength or color of light. Wavelength or color of light. So just now we have seen the refractive index is inversely proportional to wavelength of the light. Okay, then what is the relation here? I have written the color of the light. How can you say that? Well, as you know well, we have with GR. With GR, V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, R for red. I repeat: violet, indigo, blue, green, yellow, orange and red. So this is increasing wavelength. It is violet to red is increasing wavelength. Similarly, here the wavelength is decreasing, red to violet, red to violet. I will write here the wavelength of red color is greater than the wavelength of orange. The wavelength of red is greater than the wavelength of green light. The wavelength of red is greater than the wavelength of violet. I mean, it is a maximum wavelength, it is red. Okay, after that orange, after yellow, green, blue, indigo and violet. So the least wavelength is for violet, maximum for red. Okay, I have a doubt here. When the light travels in the vacuum, which color has a maximum speed? I repeat, when the light is traveling in vacuum, which color has the maximum speed? For example, if I will take the violet and red, when it traveling in vacuum, which color has a maximum? I says here, the speed of light, the red color light speed is equal to violet color speed. In vacuum, all colors travel with the equal speed. In vacuum, all colors travel with the equal speed. So it is how the wavelength, as we know, it is the relation for how the wavelength depend. And colors we have seen, red has a maximum wavelength when compared to violet. Okay, like it is. The last one is temperature. Temperature. How the temperature depends? The speed of light is directly proportional to temperature of the medium. More temperature, more speed. Less temperature, less speed. From this relation, I will write the refractive index is inversely proportional to temperature of the medium. More temperature, less refractive index. Low temperature, high refractive index. So these are the three factors on which the refractive index depends. So first factor is nature of the medium. Second, wavelength of the light or color of the light. Third one is temperature of the medium. Okay, and then the next topic we have relative refractive index. This is the most and important thing. Relative refractive index. So relative refractive index. Relative refractive index. Relative refractive index it is a ratio of, so simply I will write n. N is the relative refractive index, can be defined as, it is a ratio of refractive index of second medium by refractive index of first medium. So we will write n2 by n1. This is the relative refractive index. Then what is the presentation here? We will write n21, refractive index of medium 2 by refractive index of medium 1. Okay, it can also be written as n21. It can also be written as 1 by n12. So all are equal it is. Refractive index of medium 2 with respect to 1. n2 by n1 equal to refractive index of medium 2 with respect to 1. It is 1 by refractive index of 1 with respect to 2. And it don't have any units, no units it is. It is a pure number. S is a pure number. Okay, after that we have hot A, cold A. Which one has a high density? Yes, cold air has a high density. So, density of the medium is directly proportional to refractive index. Directly proportional. More density, more refractive index. So, hot air is a denser medium. Hot air is a denser medium. Cold air is a denser medium. Hot air is a rarer medium. Rarer medium. Cold air, density of the medium is directly proportional to refractive index of the medium. Cold air, denser medium. Hot air, rarer medium. Then we have the density of the medium is directly proportional to refractive index of the medium. The least refractive index is 1. The refractive index is never be less than 1. The least value is 1 and the refractive index is always more than 1. More than, equal to 1 or more than 1, but not less than 1. Okay, after let me see here, the speed of light in air is 3 into 10 power 8 meter per second. I said the speed of light in vacuum is 3 into 10 power 8 meter per second. Speed of air approximately equal to speed of light in vacuum. Then what is the refractive index you will get mostly? The refractive index is equal to C by V, that equal to same value 3 into 10 power 8 meter per second by 3 into 10 power 8 meter per second. So we'll get cancelled, unit get cancelled, numbers will get cancelled. Finally we have the refractive index equal to 1. So what we have learned in this class? We have learned refractive index. It is a ratio of speed of light in vacuum by speed of light in given medium. Factors, 3 factors we have seen. The first factor is nature of the medium. The second factor, wavelength of light or color of light. Third one is temperature of the medium. Relative refractive index. Refractive index of second medium by refractive index of first medium. Hot air is a rarer medium. Cold air is a denser medium. The refractive index of the medium is directly proportional to density of the medium. The least refractive index is 1. The refractive index is never be less than 1. It is always equal to 1 or more than 1. Okay, this is we have learned in this class. The coming class we are going to learn the refraction through the glass slab. Thank you. We'll meet in the coming class. Bye bye.